Now let's discuss the characteristics of a wave. There is what we call the crest, which is the very top of a wave. That's one crest, a second, a third. A trough, the bottom of the wave. The amplitude, the distance between the equilibrium position and a crest, or the equilibrium position and a trough. That's the maximum displacement the oscillating object would have from equilibrium. The amplitude is related to the energy that the wave carries. Remember, think of the spring. The compression of the spring, x, is related to the energy stored in the spring, 1/2 of kx squared. Think of it the same way. Wavelength, distance from crest to crest, trough to trough, it's the length of a full wave. Frequency, number of waves to pass a given point in 1 second. The SI units for frequency is hertz or 1 cycle per second. So if I'm here and the wave is traveling, I count the number of waves that pass every second. That's the frequency. How frequent are the waves? The period is the time it takes a wave to pass a given point, or the time to take the medium of the wave to make one full oscillation. The period is related to the frequency by t is equal to 1/f. The wave speed is how fast the wave is moving, which is different from the speed of the oscillation of the wave. So the speed of the wave is the speed of propagation of the wave. It depends on the medium, and it is related to the wavelength through this expression, v is equal to lambda times the frequency. What we call angular frequency in radians is 2 pi times the frequency. So its meaning is very much like the frequency, but it's in radians, 2 pi times f. What we call wave number is 2 pi over lambda. It is the equivalent of angular frequency, but instead of time, instead of being related to time, it is related to distance. It's related to the wavelength, as opposed to here you would have f, remember, is 1/the period. The equations would look exactly the same if I have 1/the period here. So instead of seconds in the denominator here, I have meters. The equation of propagation of a wave can be written as A, the amplitude, cosine of omega t minus kx. Remember, k is the wave number, omega is the angular frequency, t is the time, and x is the position.